Hi, my name is Alex Easton. I, along with Patrick Egan, Nick Elms, and Sammy Larson, are Group 1 for the Spring 2020 IMSE Capstone at Iowa State University. Our company operates a machine with 5 to 6 operators on 4 shifts in a block-style rotation. The station layout is as follows: 1, 2, 2B, 3, and 4, which is shown here. The company expressed concerns about large amount of worker idle time on the line, ergonomic hazards at Station 4, and wanted to investigate if installing a grinder would be feasible.
There were 3 objectives set for this project. The first was to reduce workers' average non-value-added time by 25 to 50%. The second objective is to have a risk rating of low or medium for at least 80% of the tasks using REBA ergonomic assessment. Additionally, the team aims to determine the feasibility of installing a grinder for scrap within the facility.
The team completed a work sampling study in order to quantify the amount of time line operators spent on certain tasks. After 100 observations over 4 days in 5-minute increments, the team found that Station 3 has the most non-value-added work at 61%, with Station 1 at 50% and Station 2B at 36%. On average, the line as a whole was performing non-value-added work 39.2% of the time. The team proposes to combine Stations 3 and 2B. 2B spends about 30 minutes per hour testing samples. Station 3 is idle the most at 61% and spends about 24 minutes each hour flipping rolls. With over 30 minutes of available time, Station 3 would be able to handle the task of collecting and testing samples that 2B currently does. The Gantt chart shows an updated time allocation for Station 3 after combining it with 2B. Station 3 is also located next to 2B, so there would be minimal disruption in the time spent walking to the testing location. Absorbing 2B's responsibilities will shift Station 3's non-value-added time from 61% to an estimated 25%. The average non-value-added time for the entire line will fall from 39.2% to 24.8%, resulting in a 37% reduction from the current average non-value-added time. These results fall within the team's objective and also eliminate a line position, which results in savings of $364,000 annually for the company.
Through the work sampling study, the team was able to determine that there is enough available time on the line for the grinder to be operated by Station 1 while they do their current responsibilities. This operator has at least 15 minutes of extra time to operate the grinder, as shown by the Gantt chart. From its initial observations, the team believes that the best location for the grinder is behind the resin bins, close to Station 1's area, where there's currently WIP being stored. Installing the grinder will cost $450,000, but will save the company $334,000 annually on transporting scrap.
To assess the ergonomic issues at Station 4, the team conducted a REBA analysis on 6 tasks that had the largest potential risk associated with them. The packaging of white and clear rolls were observed and recorded to study and perform the analysis. Any position with a score of 8 or above is considered high risk and should be changed immediately. 2 positions received a high risk score. Banding the white is shown on the left, which received an 8 because of the bending and reaching required. The bagging of clear, shown on the right, received a 9. The biggest issue with this position is the safety risk of standing on the thin edge of the elevated conveyor and the reaching. Multiple solutions were investigated by the team to best address the high-risk positions. For the banding of white, a banding tool shown on the left was developed by the team to eliminate some of the reaching and bending. This tool reduces the REBA score for banding to a 3, which is now low risk. For the bagging of clear rolls, the installation of a step platform should be implemented at the end of the conveyor so the workers can have a secure footing while reaching over the roll. This step would reduce the REBA score of bagging to a 7, which is now a medium risk. The team concluded these would be the best solutions because of the ease of use, low cost, and ease of implementation.
In this video, you can see how the operator needs to bend and reach in order to get to the banding pass through under the pallet. Here is now the same task being performed, but with the aid of the tool we designed. For this, we created a prototype out of simple materials such as PVC piping and duct tape. The operator starts by clipping the banding into the tool, then pushes the tool in and around the bottom of the pallet. As you can see, the operator does not need to bend and reach on the pallet or squat down to get to the banding anymore.
After considering all of the factors previously mentioned, the team has decided the most viable solution for the company is to install the grinder, remove 1 station from the line, and purchase ergonomic improvements such as a step for the conveyor, tape guns, grip tape, and the custom banding tool. All in, this would cost the company around $450,000, but would have a 3-year net present value of just over $1 million, and a corresponding IRR of 144%. By implementing these solutions, the company will move towards its sustainability goals, reduce downtime for operators, improve safety, and cut costs.